Hello, friends. Welcome to a very fundamental lecture on thermodynamics, the first law of thermodynamics. I am Professor Arvind Prasad. We know that, well, it is common knowledge to all of us. Most of us who have done our degree in sciences, not our degree in sciences, our 12th standard in science, or at least our 10th standard uh, physics, we know that energy can neither be created nor be destroyed. Now, this does not require any further elaboration. We all know whatever energy is stored in a system, it can neither be created nor be destroyed. Well, we need to think about it now. Now, let us say, supposing we take a object, we give heat to it. Does heat get stored in that object? The answer is no. The heat does not get into that object. It does not get stored into that object. The heat is stored as internal energy. Now, what is internal energy? We all know that for any substance has molecules. Any solid would have either molecules or atoms. Now, in solid, the atoms vibrate by their mean positions. But in liquids, the molecules vibrate by their mean position and they are free to have a translational motion in the volume of the liquid. In gases, the molecules vibrate. The molecules can occupy the entire volume of the container. They will have translational motion. So the sum total of all such motions, all motion require energy. Now the sum total of all these energies is the internal energy. So whenever we give heat to any body, it is always stored as its internal energy. Whenever we take a fluid or a solid or a gas and apply pressure on its surface so that its volume changes, work is done. Now, this work is stored again as internal energy. Now, let's see what if we have an open system. Now, as you can see on the slides, we have an open system. Stream 1, 2, and 3 enter this open system. 4 and 5 leave this open system. To this open system, we give heat. To the volume of this entire open system, on the volume of this entire open system, we apply an external pressure. And we also add energy to this open system by inserting a shaft in it and putting an agitator on its lower end and rotating the shaft. This is known as doing shaft work to the open system. Now, we all are aware of the definitions of a closed system and an open system. Well, I'll explain it once again here. If no mass flows in and out of this system, it's a closed system. But if mass flows in and out of the system, it's an open system. In this open system, I have just explained how do we add mass and energy. Now, if m is the mass of the system, then the change in mass of the system per unit time is the summation of all the mass flow rates going in and out of the system. For this particular system, the mass flow rates going in are M1, M2 and M3. And the mass flow rates going out are M4 and M5. Therefore, the change in mass of the system is M1 plus M2 plus M3 minus M4 because it is leaving the system and minus M5 because it is leaving the system. Note, in this summation sign, plus is the sign for mass flow rates going in and minus is the sign for the mass flow rates going out. Now, energy entering the system through flow. As we can see here, this energy flows across the boundary. Heat is an energy supplied across the boundary. Now, pressure which causes the system boundary to change and therefore work is done on the system boundary. This is also applied externally on the boundary. Well, the shaft work, of course, goes through and energy is supplied by means of shaft work. These streams flow in and flow out of the system. Now, each stream is going to have an internal energy associated with it. Now, each and every stream is going to have a pressure which is equal to the pressure at the point where it enters the system. Only then can the stream flow in. If the pressure of the stream is equal to the pressure at that point of the system where it is entering, only then will it flow through. And the stream which is leaving the system, it will have a pressure equivalent to the point from when it is leaving the system. And obviously the stream flowing out will take internal energy along with it. Therefore, the energy entering through stream 1 is M1 dot into U1, where U1 bar is nothing but the internal energy per unit mass. Now the work done on the fluid entering the stream 1, now whenever we have to push the stream into the system, we have to do work on the stream. That work will be the flow rate of the stream multiplied by the pressure at the point where the stream is entering the system multiplied by the specific volume of the fluid in the stream. The energy entering the system through flow, therefore, the total energy entering through the system through stream 1 is m dot 1 u1 bar plus p1 v1 bar. So this is the total energy entering, because as we had seen in the previous slide, along with stream, two kinds of energy enter in. One is the internal energy and one is the energy because of the stream is being pushed into the system. So therefore the total energy is m dot 1 u1 bar plus p1 v1 bar, or m1 dot h1 bar. Now h is the enthalpy, or h1 bar is the specific enthalpy. The definition of enthalpy is nothing but the internal energy plus the pressure into the volume. Now sum of all the energies due to flow of streams in and out of the system is going to be the summation of mi hi bar across all these streams. Now, let us have a look at energy that flow across the boundaries. These energy, or the energy by virtue of the streams, go through the boundary to the system. But heat, it only flows across the boundary. It has no mass associated with it, or mass flow rate associated with it. So the heat added to the system is Q dot. It is plus if the heat is added to the system, and minus if heat is removed from the system. Additionally, we have the shaft work also, which is done on the system, which is Ws dot. Now, work done by external force on the system boundaries, that is the work done by this external force on the system boundary, because this external force is going to contract the system boundary, is going to be minus P into dV by dt. Now, one might wonder, why is it minus? Well, as we apply pressure, the volume is going to contract. So dV by dt will be negative. So a minus of P into dV by dt, which is a negative quantity, will give you a positive quantity. So whenever we apply external force on the system boundary and the system boundary contracts, we say that work is done on the system and it is a positive quantity. And minus P dV by dt, because dV by dt is negative, will be a positive quantity. Therefore, the energy balance of the open system is accumulation of energy within the system, that is accumulation of energy within the control volume of the system. The control volume obviously is the cylindrical portion, du by dt, as we know that any and every energy given to a system is stored as internal energy. Now, the change in internal energy per unit time is the accumulation of the energy within the control volume. This will be equal to the summation of all the energies coming by virtue of flow, which is nothing but m dot into h bar, plus the heat added to the system, plus the shaft work done on the system, minus P dV by dt of the system, that is change in volume of the system. Note that Q will be negative if heat is removed from the system. Ws will be negative if shaft work is done by the system. Now, this is the first law for open systems. Now, first law for closed system. Can we get an equation for the closed system from the equation of the open system? Here I need to tell you, yes. The equation for the open system is a general equation. It can be modified for a closed system. Remember, for a closed system, no mass flow rate is going in and out. Therefore, the first term is cancelled. And if we say that no shaft work is done on the system, we can say that Ws is also cancelled. Therefore, du by dt will be equal to q dot minus p dv by dt. And if we multiply by dt, we get du system is equal to dq minus p dv system. Now, this is the equation for the first law for an open system. Here we come to the end of the lecture. Hope this lecture was instructive and instructional. Please like and subscribe my video. Do write your comments and have a great day. Goodbye.